All right, the last piece of 1-2 is how do we undo an exponent? How do we undo an exponent? For example, if I had x squared, how do I undo a squared? Well, think about the other thing we know with that word in it. This is called x squared. We've also heard squared when we hear the word square root, right? So the opposite of a square is a square root. If we took the square root of this expression, the square root and the squared would cancel out and we would get x. So this next definition here, a number a, oh, this is like the formal mathy definition where we take away the example and we put everything in terms of a's and b's and it gets confusing. All this says is a number a, any number, is a square root of a number b if this statement a squared equals b. And it just got like way more confusing than when we talked about it 30 seconds ago. And when that happens, put in some numbers. Okay, this says a squared equals b. Let's evaluate it for, let's say a is equal to 3. So 3 squared, well, 3 squared would have to be 9. So b is equal to 9. And now let's read this statement over again. The number 3 is a square root of the number 9. Now that's true. All right, it made a lot more sense that time. But we need this definition, so that we have a formal definition of what a square root is. But when things get sticky like that, just plug in some numbers and see how it makes sense, in context. A little bit of vocabulary over here. When we have something under the square root, technically another name for the square root is this right here. It's called radical. Okay, it's a fancy way of saying square root. And then the number, or in this case, the variable under the square root is called the radicand. Let's just take a quick peek at these examples down here. This is in this unit because we need to be able to simplify radicals, okay? So for right now, we're just going to be recognizing when things are able to come out as a square root. And if you're looking ahead at this note, if they can come out as whole numbers, we call them perfect squares. Okay, so really we're just looking to see if the radicand, the number under the radical, is a perfect square. And in this case it is 81, right? That's a perfect square. The square root of that is 9. And let me just back it up a second here to tie it in with what I said earlier. Technically what's happening there is we're breaking down that 81 into 9 squared, right? And then, like it said above, the way to undo an exponent is to square root it. These two things cancel each other out. And so that's why this comes out as 9. Just a little bit of backstory. Okay, let's do it again. The square root of 49, we know that that's a perfect square. It's 7, right? But what's happening behind the scenes is if we break that into 7 squared, then the radical is canceling with the squared, squared, and we get 7. And now this last one, 19 is not a perfect square, right? We cannot break 19 down under the radical into something squared. So this is actually fully simplified already as the square root of 19. And you might be thinking, well, I could throw that in my calculator though and find out the decimal value. And that's where I would say no. Okay, simplify means write as in its simplest form, which is in this case square root of 19. writing something as a decimal is actually changing its number, okay? Because if you threw square root of 19 into your calculator, you would get a irrational, never-ending decimal, get an irrational number. And then you can't write down an infinite number of numbers, so you'd have to round it, and you would round it to something. And in doing that, you actually change the meaning. So whenever it says simplify, and we have a radical that's not a perfect square, so we cannot simplify it, we're going to leave it as is for now, and that will be fully considered simplify. Okay?